Yes, hello once again. Welcome to this video. Today, I'd like us to talk about the resistors. I'm going to show you how to test for faulty resistors and how to measure resistor, when it is good or when it is not. So we shall be using these motherboards. So I have few of the motherboards here. Some motherboards are working, some are not working. They are dead. So we are going to use them to learn how to test for an SMD resistor. So we are going to test for the SMD resistors on these uh, motherboards. First of all, before we focus on the practical or the testing side, I like to introduce you. I think you love to do some writings. I don't know where I placed my pen. I got a pen somewhere. Oh yes, it is. So first of all, we are going to start with the theory, introduction about the resistors. What are the resistors? What they do? And a few discussions about them. A resistor, this is a component within a laptop motherboard which uh, limits amount of current which passes uh, along the power line. Yes, these components are normally placed along the power line whereby they can limit the current going past there. It limits the current so that it can protect the rest of the intended location of the power where it is going. So we are studying about the resistors. Resistors, we say these are components. So this is a component which uh, limits limits amount of current which cross over the power line or the power line. Yes, power line is one and the same thing. Yes. So this power line is the route. These are pathways of the current, and that current is either regulated, limited. Yes, because it needs to be checked before reaching the intended component of the motherboard or before reaching the main motherboard. That's why it needs to be checked. Yes, that's why you can find some components switching that power. There is some are filtered like a capacitor. They check it by filtering or ensuring the steady flow of it. Here we have now another component which is called the resistor, which ensures that the current is limited. Yes, it limits the current. So this resistor, we have several types of them. Yes, we have resistors which allows uh, current to pass through without any kind of resistance. Some some resistors allows current to pass over by reducing the amount of current which is passing by there. That's why we say it limits. It squeezes that power which is going along the power line. Some resistors even doesn't allow any power to cross over or to pass to the other side of it. So a resistor is a component like this one. Let me just show a little bit some of the examples of the resistors. A component like this one. This component, the middle, you find that the middle is black component. This is the solder. This is the solder part. So these sides are the solder. You could find a component which is that way. It might be a component with big dark center side, or a component with a small darker center side that way. Sometimes you find a resistor that is black that way, but in the middle it is black, however, but it has some writings on it. You could find this written maybe 4R7. That 4R7 means something. You could find the resistor which is this way, and the middle there's certain number written on it, maybe 0603. You could find another component or a resistor this way, and still a black component, but in the middle it is written maybe 000. Or you could find another one written maybe 100, maybe that is 100. Another one, it is written 1,000. It's written 1,000. It is 1,000. You could find another one. Maybe it is written 222. You might find another one. This one is written R005. You might find another one written what? There are several of them. You might find another one which is written. This one it could be just 10. You might find another one maybe written what? We are going to discuss all of them. Maybe written 2.3. You might find another component, another resistor, which is written 1R5. You might find another one. These are our resistors. These are our resistors. At the middle of it is black. You might find this one maybe written R68. Don't want to continue. In fact, there's a very then, however, we have another tiny one. Tiniest of all. I'm going to show you on the motherboard. We are going to look at all of this and compare with what I just showed you. This component, this one, these two, which are black in the middle and they are big enough, they are big. You cannot compare with this little one, this very little one. You cannot compare with it. Excuse me with my flu. So these ones, they have 0.00 resistance. Yes, the measurements for this, they have no resistance at all. That one have no resistance. This one with an R code, that R, it means this is a decimal. So the reading for this, for example, is 4.7. Yes, if you have maybe 2R2, it means that's 2.2. Yes. With this one, if you find a resistor which is labeled like this one shows the size of this resistor in terms of inches. So here, describe resistor in its size. Describes a resistor in its size. So this one actually means it is 0.6 inch by 0.03 inch. So this is the length by the width. So this is length, that is the width. That is what that means. Once you have a resistor written 000, this one still like this one, it means it has 00 resistance. This 00 means that resistor is continuous. It's generally just a wire. Yes, this is a complete wire which is crossing over to the other side. That's why it has no resistance. Even this one, it is a wire. It's like a thin film inductor. Yes, it's a thin film inductor. Then next, if you find a resistor which is labeled 100, that resistor, it means that is 10 times 10 raised to 0. That last digit, that is the multiplier. So you will take the first digit except the last one times 10 raised to that last digit. So this one, it means this is 10 times 1, because 10 raised to 0 is 1. So meaning this one is 10 ohms resistance. So that one is 10 ohms resistance. So this 4.7 resistance ohms, that is 4.7 ohms. This one, which is written 1,000, is like this one. So normally these are 3-digit code. So we call it 3-digit code. 3-digit code. This 3-digit code uh, is the coding which represents a resistance of what? It represents a resistance of over 10 ohms. So it's 10 ohms plus. Yes. from 10 homes, 11 homes, 100 homes, 1,000 homes, and so on and so forth. Then this 1,000, it means this is 100. You take the first three, the first numbers except the last one, times 10 raised to the last one now, which is raised to 0. So meaning this is 100 times 1, which is the same as 100 homes. Still, it is the same as this one. It is the same as this one. However, this one we call it a 4-digit code. 4-digit code. 4-digit code. Then finally, you have this one, which is not finally, but actually next one is this 21222. This is the same as this one, is 3-digit code. So it means this one is 22 times 10 raised to 2. 10 raised to 2, that is 100. So it means this is 2200 ohms resistance, which is also written as 2.2 kilo ohms. Yes, because 1,000 ohms is equivalent to 1 kilo ohm. So this one is also written as 2.2 kilo ohm. R00, instead this R00, it means that is the point. So it means if any number coming after R, it equates to 0. So probably this resistor, the value of this resistor is 0. It could be 0.2, 0.02, 0.005, 0.5. So it means that's the 0 ohm resistor. Yes. And this, I'm going to explain to you some of these things more and there. 0 ohms resistance, still this is a 0 ohms resistance. So all of them are 0. No need even write 0.0. Any resistance which is below 0, that is 0.9, 0.1, 0.5, that is a 0 ohms resistance. So however, if it is above 0.5, sorry for that, any resistance which is below 0.5, that one is treated as a 0 ohms resistance. But if it is above 0.5, maybe 0.7 ohms or 0.8 ohms, that one can be, you can round it off to 1. So it will mean that is a 1 ohm resistance. 2.3 ohms, it's the same. This one is also same as written to R3, which is equivalent to 2.3 ohms. Yes, 2.3 ohms. This one, 1R5, of course, I know you know, R represents point, so that's 1.5 ohms. Then R68, this is 0 ohms. So this can also equivalent to 0 ohms resistance because this is R coming after. So the number is coming after an R. So it will qualify to be a 0 ohms resistance. Then finally, you have the tiniest of all. See, this tiniest have resistance. This one have resistance. However, the amount of resistance for this one varies. You could find some having 20 ohm resistance, 100 ohm resistance, 150 ohms, 200 ohms resistance. It's somehow like this one, but they're not predictable. It has no value in it. It has no value in it. So maybe if I can add more on what we just discussed. So out of this we just discussed, we found out that. So this one we said, where did we label that? Okay, yeah, we found out that each resistor there's a system of naming them, and the common naming for that we have like 3. Yes, what we just saw, we have 3 naming. First one is we said you have R coding. Yes, we call it R coding or R notation. That R notation, it is used for low values where the decimal point is needed. For example, this one for what? For R7. For R7, this is a small value which is below 10. So if this for R7, that means that is 4.7. If it is what again? Where is another resistor having an R? Even this one. Yes, this is a low value which is below 10. That's why they are using what? They're using R. So whenever you see a resistor which is having an R or a dot like this one, it means that value is too low and it needs a decimal place. And that decimal could be an arc or just a dot to represent a decimal. Then, apart from R system, we have also three-digit code or three-digit system. That three-digit system, like this one, where is it? The three-digit system, for example, this one system. So the first two numbers, for example, what one, two. So this digit, the first two digits are significant. The first two digits are significant. While that one is the multiplier. Yes, if it is three digit, so you just take the two first, then you multiply by 10 raised to that last digit. And the accuracy for this is plus or minus 0.5%. So, meaning we might not get exactly the same value. For example, this one for 100, this is 10 raised to, this is 10 times 1, which is 10 ohms resistance. At 10 ohm resistor, we might have it as maybe 9.8 ohms. It could be 11.1 ohm. Yes, as you can see, it's not exactly 10 ohm resistance. Yes, to have that error. Then the fourth digit code, like this one, the fourth digit code, this one, the accuracy for this is plus or minus 1%. So we'll have it around there. We'll have an error of plus or minus 1%, not one, but 1%. So the first three digits for this four digit code are the significant value, while the last one is the multiplier. For example, if you have what, yeah, let's say we have this 1,000, so this is 100 ohms. If it is with this 1,000 and two, what does this mean? So this one is 100 times 10 raised to 2, which is the same as 100 times 100. So this is what? So this is 10 kilo ohms. Yes, 10 kilo ohms or 10,000 ohms. You can just find it that way. What about 49? Let's say we have a resistance of 6998. What does this mean? This one means this is 699 times 10 raised to 8 resistance. So, which is equivalent to 699 times 8 zeros. Man, 1, 2, 3, 4, 5, 6, 7, 8. How many of these? This is like 699,000,000 kilo ohms. Hey, you see? Yes. So one last digit makes a very big difference. You can see? Yes, it really makes a very big difference. So guys, let me hope you get something, you understood something. Yes. So let's have allow us to measure some of the resistance on the motherboard. Like us to measure some of the resistance on the motherboard while comparing with the values we just gave out. So how do you measure them? You need to have your digital multimeter. You need to have a digital multimeter. So this is my digital multimeter. We need to power it on into the resistance mode because you like to see the coding. Here is my meter. As you can see at the top here, we have the values for the resistance, for the ohms. We have the values for the beeping, diode mode, and capacitance mode. So we are going to power on my meter. Then my reading should be in the ohms mode. Yes, that is the resistance mode. As you can see, it's reading mega ohms. Now you're going to start with this. You're going to start with this motherboard, and you're going to start with our first what? Our first resistor. This one. with a black middle, a black middle. So my meter is in ohms mode. Let's locate that capacitor. Let's relate that resistor. Sorry, here it is. Can you see this, which I pointed out here? Yes, we are going to measure it and see actually how much resistance does it have. So it is here. It is located here. You can see. Yes. Let me just bring it up closer so that we might read it. We are going to read it here. So that resistor is here. So you're not able to read it. Let me put it here. Yes. I believe you can see I want you to see the screen of my meter as well as yes, that one. As well as this value as I measure this. So the resistor is this. Looking for the readings 0.1. I said if it is 0 point something, so long as it is below 0.5, that's still equivalent to 0.000. So that's a 0 ohms resistance. It has no any resistance, that's why it is reading that value. Yes. Then apart from that, so these first two have been represented. Can we have can we see any other? We can even use another resistor if it is here. Yeah, I'm not seeing the black one, but it should be there. However, let's eliminate all about the zero resistance. In this one, I am having this type of resistor. Let me show you. In this one, I am having this resistor. This one, R005. Here, that resistor is here. However, this one is R000, or this is R010. Yes. What did I say? R010. So long as the value coming after R, that one is equivalent to 0. Yes, when you see any number coming after R, that is 0. So R010 falls under this. This is R005. So let's check that R010. How much resistance does it have? That R010 is here. You know, my camera is not focusing right now. This big resistor here. Yes, I believe you can see here. That big resistor is written R010. It is written R010. So let's measure how much resistance does it have. That resistor is having 002, which is also the same as 000. So I want us to be done with the 000 things. So far we are done with this. We are done with this. We are done with this. All of them are in the reversal. Or do you have any other one here? We can't use it against to verify that. Yes, for the R005, it's not visible enough, but I have a very black component here. That component here, this, let me just point out directly. This one. This component is a resistor, and at the top of it, it is written R005. So this one now represents this actual R005 we cut here. So let's test it, let's measure it. As always, I want you to see the screen. Focus on the screen. Trust me here. I'm the one measuring the resistor. The resistor itself is this one. And the readings is 0002. So meaning all resistors of 00 are 0 something been represented. So this one, the one which read what? 000. Any other one? I want us to represent all of them in this motherboard. I thought there was one here. Yes, another one, which is R005. This one. This one still. This R005. So the R005 again. Let's see if it belongs to the same family. So the R005, the R005 is here. This PR917. 0000. So guys, let me hope we are in agreement with that. If you are disputing anything, you can put it on the comment section so that we can discuss. So those ones are done. Now let's verify this. The next is what? I believe what about we haven't verified. We said we finished about the zero. What about this one, which is written zero? The resistance which is written zero is like what? Let's locate some of them because I think we can have some of them, especially they are for power line. And in fact, we even forget to measure this again. This is also R005, which they have the same value like the rest. Here, I have tiny one here. This tiny one here, it is also written zero in the middle. If it is written zero in the middle, it means it is having a zero resistance, and we are going to measure it. We are going to measure it to see whether it is indeed zero. So that resistor here, next to the interseal 9538H, that resistor is having 0003. Yes, it's having 003. What about R005? This is R005. I just told you 000. This one now is going to 1 ohm. What the hell is wrong with this? Turn back to the yes. This one is 000. Yes, maybe the readings was not yet stabilized. Yes, or maybe because this motherboard I think it is shorted. That's why we have those kind of readings. So meaning, what does that tells us? Before deciding to announce your reading or to confirm your reading, you need to do what? You need to wait for your meter to stabilize. You need to wait for your meter to stabilize. Now, we've seen for the zero, it means a 0 ohm. Do we have another one here? We can just use this other one to confirm our theory. We can use this other one to confirm our theory. Let's locate the resistor which is written 0. Yeah, there are several of them here. We have several of them here. I have one here. Then I have two here. Let's confirm that. Let's confirm that. So let's either there. Then those resistors are this one 02, this one 00, this one that one should be 00. Does that tells you if you see an OL or a large resistance, a large amount of resistance, it means that resistor is blown up. So Excuse me. I'm so sorry about that. So this resistor, I believe it is blown up. That's why it's not even reading the readings of this of the other resistors. There it is. Now it is stabilized. So the same what just happened. It's the same, guys. Let me just bring it closer to you. Let me just put it there. Then the resistors I'm measuring. Can I place this? Can I place it here? Yes. Pay attention to the port here, the meter. So my resistor is here. Then when I place it this way, now you can see it's below 0.5. So it means let me see it. Sorry, my camera is somehow not focusing very well. Sometimes it focuses, sometimes it doesn't. So I don't know. It bewitched my camera. When I want to show something, that is when it stops focusing. Yes, there. And this other one, there too. Yes. So many of the 0 billion, the 002s represents the rest of the resistor. So meaning this one, we're done with that. Yes. So we are done with the zero resistance. Now let's check what? Let's check another one. Let's check this one for what is our next? This one we cannot measure this because I said this one. You can see it starts with a zero. Start with zero. Maybe if it is 0.820. No, there's nothing like this. Maybe 0.802. It means this is a 8 inch by 2 inch. That is, this is the length and the width. Yes. When it starts from zero, that is 0.904. 9 inch and 9 inch, 4 inch, which is 9 in length and 4 by width. So this one you're not going to test this because there's nothing to test there. That describes the size of the resistor. Next is this one, 4R7. 4R7 means that is 4.7. Okay, we are going to test that 4R7 anything with R except this one. 1R5. What else? Yes, and any other R in between. We are going to test them so that we confirm any value, any resistor with an R in between a digit. It means a point. It represents a point. For example, we are going to use what? We are going to use we're going to use which one? This is a big one. We can start with this one. This one is written 4R7. This one is written 4R7. Can you see it? Yes, it is written 4R7. My meter wants to shut down. Let me just make sure it's not shutting on me. That 4R7, how many values, how many readings can we get? Pay attention to the meter as I showed you. So the resistor is this. Pay attention to the meter. The resistor is this one. Resistor 4R7 reading 4.9. Reading 4.8. Yes, 4.9, 4.8. That's good. Even 5 is still within the limit. Yes, even 5 is still within the limit. Is there any data within this motherboard? I am not seeing any other. So let's see whether we have another 4R7 with this. In this one, There is none. There is no resistor written 4 or 7. However, there is 2 or 2. What do you think 2 or 2 will read? It will read 2.2. So this is 2 or 2. It is reading 2.3, which is very accurate. That's good. And remember, guys, since you know, even there's another one here, there's another one, 2 or 2 here. I'll just put it this way, and you can see, yes, here we have another resistor which is reading 2 or 2. That resistor is reading 2.3, which is also very accurate. It's also very good. So, guys, this resistance, these values we just measured, if it is 2 or 2, it should read there, that 2 or 2, 2.2, 2.3, 2.4. If it will read a very big value, for example, maybe 10 ohms or 100 or 1,000, it will mean that that resistor is blown up. That's why there's no that little continuity. Yes, it must have a certain resistance. If it is having so much resistance, it means uh, there's no connection. There's no connection between one point of the resistor to the other. You know, a resistor needs uh, needs a little bit of the continuity. That is why these resistors, you have some of them having different resistance than the others because they're designed to do specific to limit a certain amount of current. Yes, some are designed to allow much current. That's why they have a very low resistance. Some even have no resistance at all, so that they can act like inductors. They can act like fuses. Some have a little bit of resistance so that they can allow a certain checked amount of current. Some have big resistance so that they don't allow any current at all to pass through. Yes, I believe you're getting why we have different uh, types of resistors with different value of their resistance. So, having said that, having said that, let's check this other motherboard whether we have another resistor which can give us a different idea why these resistors have varied amount of resistors, yet all of them are resistors. Yes, here is another one. Here's another one, and this other one it is 4R7. Yes, I have 4R7 here. Let's see that 4R7. What does it read? This 4R7 is here. Let me bring it closer to you. It is here. See, this is 4R7. And what is the value of that 4R7? Let's see. This 4R7 should read around 4.9, 4.8, 4.7. This one is reading 5.0. Let's wait for it to stabilize. Nevertheless, it is blown up. Now, maybe I'm not stable enough. Let me just put it down here. Let's wait for it. 4.9. 4.9. That is good. That is good. So far, we feel straight. about the R resistors. In fact, we've last read about 1R5. What about 2.3? Where there is a resistor written 2 point something. Let's see whether I can get one. Yes, one. The first small though. So I don't know whether you are able to read it or you are able to see it. The first small one. Here. Yeah. Or is yeah. Here is a resistor which is written 2.3 or 2.2, something like that. So you're going to test it. You're going to test it. Let me put my meter there so that you can read it clearly. That resistor is here, and the readings is 2.4. I believe this is 2.3, 2.2, but our reading from the meter is 2.4. So it means that is an accurate resistance. And here is another one which is like, is it 5.1 or 1 point something? You can see clearly. 5.5R1. Yes, 5R1. It's reading 5.3, 5.3, which is good. Here I have 2.2. 2.2 is having 2.4. As you can see, most of these resistors which are somehow near the processor, they have some resistance, but not big resistance and not less resistance, because it allows certain amount of current to cross over, because that current which is needed there is a current to power on the processor, so it needs to be checked. So this one cleared. Which one we haven't cleared? We haven't cleared for 100 and 1000. So let's look for 100 resistance and for 1000 resistance. Can't see any. Here's another one written 3.3, 3R3. So 3R3 should read 3.3. Let's see, 3.6. Yes. So this one, you're done with this, not unless it is having what you're looking for. And it is read having. So here I have a resistor here which is written 100. So guys, just put back this one, trying to disturb me. Here's a resistor which is written 100. I don't know if I can see it. I have a very big reflection here. This one. Or this is too much light. Can we try to switch it off to see whether it's visible? And if there is the darkness. Yes. Tell my darkness, welcome. You will not see nothing. I just put back my light. Yes. There's a resistor here. Can I put it so that you can see? However, it is somehow tiny though. So let me just test it and you can read the meter. It is reading 10.3. 10.3 meaning it's also correct. If you also have your meter in a certain motherboard in your bench, you can just test for yourself. Yes, that 100 ohm resistance, that 100, it means that is 10. I can't see any other Incase motherboard. Then we hope I can locate very big one here, which we can measure together, which will be feasible for you and me. I am not happy when I found myself it's only me who sees that resistor. Yes, it's not making me happy. So my guys, I don't know how I'll find a very big one so that you can so that we can see together. Found another one, but still very tiny. still very tiny. This one here is a resistor, and that resistor is reading 100. Is it 100? Yes, it is reading 100. Maybe you can try to measure it together again. Here, that resistor 10.2 ohms. Can't see another one. Cannot see another one. Just put this on the side. You're going to use a different motherboard. When we have among the motherboards we are cutting, we will put at least one big resistor which is having 100 ohms on it. I think I have another one here, but this one is for the MacBook, so that one it doesn't have. This one is fallen over. I don't know whether we can get this in case Lenovo. I'm sorry guys, I can't get it. I can't get the very big one which you can choose to use to verify our theory. However, I can see we have some small ones here. These small ones still they are written 100. I have two of them here. These two of them they have 100 on it, so it means these are 10 of the resistance. This side 10.3. About this one 10.3. Yes. So we are done with this. Let's see what we can get for 1000. If you can get from your side, you can confirm it for yourself there, so that you can save time. If I get one, we are only going to use that one of them, so that you cannot waste more time. Don't want us to waste more time measuring these things, because I believe so far we've understood how to test for good and bad resistors. Yes, a bad resistor or a faulty resistor, you'll find that it is having more than the resistance which is written on top of it. Because I can't get one, and I thought I had seen it before we started recording this video. I don't know why it disappeared too. Maybe it feared that we might get knowledge. That's why it disappeared. I don't know why it disappeared. Have you realized that whenever you're looking for something, that thing disappears? Well, when you're not looking for it, it's on your eyes every now and then. I was looking for 1000 home resistance, but I just got 10. This is another one for 100. This is another one for 100. It might be feasible because somehow it behaves like it is feasible. This one. Let's see the resistance of it. What is it? 10.3. You see? I wish we found the one having 1000 on it. That one which is having 1000 on it, it means that is 100 ohms resistance. No guys, you cannot get it. Not today. But here I have another one which is written 1RO. So this one should be what? It should be 1 ohm resistance. This one, there's a resistor here which is written 1RO. This resistor is written 1RO. Let's see the measurement for it. This one is reading 12. Does it mean it is blown up? Yes, this one is blown up. It's not reading the readings. But yes, that is it. This one is reading 1.6. Yes, this is reading 1.6. I'm not getting the resistance we are looking for. The one with 1000. I'm not getting the one with 1000 only. That's good, What does it mean? So we are done with that, even though we didn't get it. What about this one for 220? 222. I don't know where we'll get that. There are, yes, we'll find them in your motherboard. Me, I can't get it in mine. So you'll get it in yours. So guys, that is how you confirm a good working. Here it is. Here, I didn't get 222, but I have 220. Yes, I didn't get 222, but I have 220. Can you guess? 220 have what? Anybody? 220, it should read 22 times 10 raised to 0, which is 22 times 1. Should give us 22 ohms. And there is your reading. The rest are 2.2, 2R2. So it's 2R2. Yes, yes. That's how you confirm working. That's how you test for a resistor. That's how you test for a good and a bad resistor. So far, this one done. Which one we haven't tested? This R68 and the black one. R68, we are really good. In fact, there's nothing like this. This one is an inductor. An inductor is this. That one, inductors are this tact one. Normally, here at the top, it is written R68, but that's just a code which is used to different, differentiate those inductors. This tiny one, the last one, is this tiny one. This is the tiniest component of all, the black tiniest component in your motherboard. The tiniest is the high value resistance. In fact, most of them they have infinite resistance. Why? Because they don't allow current to pass through. Why do they not allow current to pass through? Because most of them still, you can see this one is having 368.9, 369.3 kilo ohms. It is written K ohms. They are down. So it means they have a very high amount of resistance because most of them doesn't allow current to pass through since they are majorly for protections. Yes. These tiny resistors majorly they are for protection. In fact, some of them they have infinite resistance. You can see this one, 2.199 kilo ohms. I'm trying to measure several from different parts of the motherboard so that you can get something out of it. This one, 2.18 kilo ohms, and you see this one behind here is the processor. Here I don't have any processor around. Here is this big chip. What about here? We have another chip here with some resistance here. Here the resistance for this is 4.6. Did you saw here I had 2 point something kilohertz, 4.6 kilohertz? Here I had about 200 kilohertz, or what was it? 369, 368, 369 kilohertz. Whereas, what about here near the port? What are we having? Here I have 99 kiloohms, that is 100 kiloohms. What about this chip? There's another chip here. The resistor which is here is having 100 kiloohms. So these resistors which are near the port, they have about 100 kiloohms. This one at the processor, you found that it is having like 2 kiloohms. Here it is having 2 kiloohms. Here 300 kiloohms. Here 4 kiloohms. What does that mean, guys? It means even though they are tiny, they are the same, almost the same size, but they don't have the same resistance. That's why you cannot replace a resistor which is here with a resistor you are taking from somewhere else far away from the processor, or with a resistor you're taking from somewhere else which is not having any relationship with the processor. Why that's so? Uh, these resistors which are found near the processor, some of them might be designed to allow a very specific amount of current to cross over. Some of them might be designed to allow much current to cross over. So meaning if you replace a resistor from near the processor with a resistor from somewhere far from the processor, that resistor might either allow the power which is not needed, or might uh, fail to allow power which should have been needed by that uh, part whereby that current should have gone, and that will bring problem to your motherboard. Your motherboard might fail to power, or your chipset, if it was the chipset you are trying to make sure it's powering on, might fail to power on, or it might short. You see this? This is the resistor which is near the SIO, that is the system input output controller chip, that is SIO chip, which manages the power within the motherboard. You can see that the resistor inside it is 1 kilo ohm. Now let's see this one. This is another chip. This is the charging IC. Let's see this resistor which is here. How much does it have? 100 ohms. You see this tiny resistor which is the same in size. You can see this one of these ones. This tiny resistor which is the same in size with this one. This one. I have one resistor here, very tiny one. I have another resistor here, very tiny one. The two of them are the same in size, but they have different resistance. That is why when you find yourself replacing a small resistor to another small resistor in a different location, your motherboard might fail to power on. And that as a technician, we find ourselves in a very tough position while repairing a motherboard whereby someone else has the drive to repair it, because that person might have tried to replace a very small resistor which was, maybe it's good, it was faulty, but the location of that resistor was a different location from where that person removed another resistor where he placed it there, and we will find ourselves in a hardship position uh, to locate that resistor. Yes, and it's very tough though. That's why repairing a motherboard whereby someone else has tried to repair is tough, and we normally charge more money for that because it's confusing, right? Yes. So guys, out of the discussion we just made, let me trust you will not have any problem testing a good Sorry, my meter has just fall down. Maybe it's tired of me. Yes, maybe it's tired of me. I'm also tired of it. I am tired. And thank God it fell down when we just finished our discussion. So far today we discussed and measured every resistor in the motherboard. Yes. So let me believe there is no any day you will get confused in testing the resistors. There's no any day you will be stuck verifying the good resistor and the bad one. Right? Yes. Guys, I'm so tired and thank you so much. Thank you so much. This has been a very lengthy video, and let me trust that out of this lengthy video you get to understood so many things. Yes, let me believe you understood so many things. I'm very happy that you've been patient enough for 1 hour, over 1 hour. We discussed this for over 1 hour, and you never get tired watching me. So, guys, thank you so much. I'm really happy, and let's grow this family together. In case you haven't subscribed, still I'm really requesting you guys, please subscribe to this channel so that you can grow together, as we shall be sharing a lot of content about laptop repair this channel. And still guys, we have an online class going on right now, so we don't have an intake. Our next intake will be on March. So if you're interested in learning about laptop repair and you are far away, you can send me your details. I have my WhatsApp number there on my profile. You can just send me your details there so that I can give you, or you can just text me there so that I can give you an email whereby you will send your name so that we can plan topologies, and then we can discuss for a next timetable of the coming March. So from 2nd March we shall have another intake the next class. Yes, if you're interested, you can just text me there so that we can discuss way forward. Again, we do teach offsite. Yes, if you're also interested in learning offsite, you're highly welcome. We are together in Nairobi. You can also text me so that we can discuss way forward. And we also do laptop repairs. If you know someone who is having the problem with the laptop, and or you know if his or I is having trouble with his or her laptop, or even you yourself is having a problem with your laptop, you can just send it to us, or you can just contact us. Then we can plan on how we can help. I have so many talks, so you will excuse me with that. Thank you, guys. Please subscribe to this channel, share with your friends, and see you in the next video. Goodbye.